Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on design of Pelton wheel. How to design a Pelton wheel, we'll see here, and what are the parameters are required and how to identify these parameters. So here I've taken a question of like a Pelton wheel is to be designed. In the first line itself it is given a Pelton wheel is to be designed for a head of 60 meter, and when it is running at 200 rpm, the Pelton wheel develops 95.6475 kilowatt of soft power. The velocity of buckets equal to 0.45 times of velocity of jet. So velocity of bucket is equal to 0.45 times the velocity of the jet. Overall efficiency is given 0.85 and coefficient of velocity is equal to 0.98. So here if you see the question, it is not given any kind of like determine these things or find out these things. So nothing given. Only they have given a Pelton wheel is to be designed. So when the point is given like a Pelton wheel is to be designed, you need to immediately understand that basic parameters like what I have told you in the last lecture. So these are the parameters, or these are the points need to be identified. Anyway, so let's solve this one. So first of all, we need to write down the data given, which is given in the question. So in the solution, we can write first one. In the first line, you can see the head of head is given. So head H is given. This is 60 meter. Next, it is running with a RPM speed. So speed N is given 200 RPM. And next is given it develops a soft power. So soft power equal to 95.6475. This is kilowatt. And the velocity bucket. So velocity of bucket in the sense the velocity of the blade. So that is U. U is 0.45 times. 0.45 times then the velocity of jet. That means V or V1 we can write. And overall efficiency, that is eta O, that is given 0.85, and coefficient of velocity, that is equal to, that is CV. CV equal to 0.98. So these are the data that are given. So design of Pelton wheel means we need to find out first one. We need to find out all these things like diameter of the jet. So diameter of jet is nothing but small d. Okay. Similarly, we need to find out diameter of the wheel. Diameter of wheel in the sense that is capital D. Next, we need to find out the buckets, number of buckets, and width of the bucket. So width of the bucket, number of bucket, depth of bucket. So you can see here I will write width of bucket and depth of buckets and number of jets. So number of buckets in the wheel. So number of buckets on the wheel. So these are the things we need to calculate so that we can design a Pelton wheel. So first of all, let's find out the small d, capital D, then we'll go for width and number of buckets, width and depth. Yeah, so first of all, we need to find out the velocity of jet. So velocity of jet equal to, let me write, these are the things we need to find out actually. Let it. And velocity of jet, we know that V1. So V1 equal to, we know the formula, this is CV into root over of 2GH. So CV equal to given 0.98 and root over of 2 into G value is 9.81 and H equal to, it is given in the question already, 60 meter. So if you solve this one, you can find out the value of V1. So let solve it. 2 into 9.81 into 60 and root over of this 34.31 into 0.98, it will come 32, 33 will come. Yeah, 33.6. So here we can write, we got the value of 33.62. This equal to 33.62 meter per second. So this is our V1 we got. Now we need to find out U value because U is given, you can see U is given, this is 0.45 times then the velocity, okay, jet velocity. So this is 33.62, okay, just you will get near about 15 or something will get here into 0.45. Yeah, 15.13. But it is half, then half of this actually. So this one 15.13 meter per second. Now we can write, we know the formula, like velocity of bucket or velocity of the blade u equal to, we know that pi dn by 60. This is another formula. So from this formula we can find out the value of d, diameter of the wheel. So this is nothing but 60 into 15.13, so this will be 900, and this is divided by pi into n equal to 200. 200 into 3.14, this will become here about 650. So here 900 by 600, so we'll get 1.5 something will get. So let's solve it into 60 and divided by bracket pi into 200 bracket close, 1.44. So here we got the value of d equal to 1.44 meter. This is our one answer. Okay, now the second answer we'll find out here. This one calculated. Okay, now we'll go for the second one, this one. Okay, so diameter of jet. So diameter of jet equal to, so where you can find out the diameter of jet? Now we know that our q equal to av, q equal to av, and here you can find out pi by 4 d square into v. So in this point we can get the value of diameter. So for this we need to know what is the discharge value. So for discharge, to find out the discharge value, again we need to go reverse, like we can find out this formula from the overall efficiency. So overall efficiency equal to, we know that this is soft power by water power. So soft power already given in the question, that is 95 point, this is 6475 into, we can write 1000, because kilowatt given, let convert into watt. And water power actually, no, let keep it in the same kilowatt, and this water power actually, this is rho g q h by 1000. The 1000 only I have written in the top. Okay, so this rho will be cancelled, and here we can write, this is, now see, in this formula overall efficiency values are given in the question. Now g known, h known, only q is unknown. So here again I can write, this is q equal to, I can write this is 95.647 divided by overall efficiency, this is 0.85 into 9.81 into h equal to 60. So we can find out the value of q. So let's find out 95.647 divided by bracket start 0.85 multiply 9.81 multiply 60 bracket close equal 0.19. So the discharge we got here 0.19 one something, that this is meter cube per second. This much discharge is there. Now we got this value. So here we can write, as I told you, this formula. So I can write this like d equal to, I can write d equal to q 0.191, this one. From here I can write d equal to, let's take this value here. So this is 0.1994 and divided by pi into v. Pi into v. V is how much? V is 33 point, it is given 62. So 33.62. This is of d square. So now d equal to, I can write root over of this. So I can find out the value of d. So what I'll do here, first I'll multiply, then I'll go for the root over. Yeah, already this value is there. Multiply 4 and this divided by bracket start at pi into 33.67 bracket close. Okay, and we got this value square root of this 0.085. So 0.085, this is meter actually. Okay, so we got here 0.085 meter. If you want to convert into millimeter, then we can write this is 85 millimeter. So this is another one answer. Okay, second one, this two calculated. Now remaining things are very easy, simple actually. So next is, the next one is size of the bucket. So size of the bucket will be calculated size of bucket. This is very simple. The size of bucket will be calculated by the simple formula like 5 into D. So D already we have calculated. Just to multiply with this one, we can get it into 5, 0.42512. So we can write this is 0.425, or we can write 425 millimeter. This much meter and this much millimeter. So this is another one answer. Now similarly, one more also you can find out here, that is depth. So the next one is depth of bucket. So depth of bucket, which we know the formula like 1.2 into D. So 1.2 into D, that means let multiply with directly that mm value 85. So if I multiply with this one, then 1.2, that is 85 into 2. This is 170. So 85 plus 17. So that is 102. This is the depth of the bucket. And the final one is we need to calculate, as I told you, number of buckets. So number of buckets will be required. Number of buckets on the wheel. On the wheel, that means how many buckets will be fixed on the wheel, that also can be calculated by this. So what is the formula for this? Like a Z equal to 15 plus D by 2D. So obviously it will be more than 15. So 15 plus D equal to 1.44. 1.44 divided by 2 into small d. Small d equal to how much? Yeah, this is 0.085. So you can write this is 0.085. So we can get like Z equal to 15 plus, yeah, let's find out this, 1.44 divided by bracket start 2 into 0.085 bracket close, 8.47 and plus 15, 23 point something there. Yeah, so this one we can write 8.47 and we'll get here which is 23.47, or we can say Z equal to 23.5, or we can take it 24. So near about 24 number of buckets are fixed in the wheel. This is our final answer. I hope you understand how to solve it. Only the thing is we need to remember that when the question is given, a Pelton wheel is to be designed, okay, other things are not there, only these are the data is given. So we need to assume that we need to calculate that these are the parameters like diameter of the jet, diameter of the wheel, and number of buckets required, and depth of the bucket, and size of the bucket, like width of the bucket. This is size of the bucket in the sense this is actually width of the bucket, first one. This is width and this is depth. So I hope you understand this problem. If still you are having any kind of doubt regarding this, you can give a call.